So let's start with the new topic, Introduction to DeepSeek. Now, whenever we discuss about generative AI, currently in the market we come across two names, ChatGPT and DeepSeek. So in this session, we are going to discuss how does DeepSeek works and how does ChatGPT works. So let's take up first DeepSeek. And the latest model they are using is R1. So when we discuss about DeepSeek's architecture, so DeepSeek is making use of transformer architecture, but with an added mechanism. This added mechanism is called as mixture of experts or MOE architecture. So let's take this use case. In a company, we have these 4 employees. And such, we have 4 teams for these. So in a company, we have 4 employees in each team and we have such 4 teams. To manage each team at the top, we have a leader. To manage each team at the top, we have a leader. And above that, so to manage each team, we have a manager. To manage these managers, we have a director. This director is responsible to understand how are these teams performing and which team to take response from. So given a use case, let's say we have a judge. For this given judge, we have been given 2 or 3 judge panels. These panels are supposed to analyze the proceedings of the case. Based on the proceedings of the case, the judge is going to listen to these panels and understand what should be the outcome result here. Similar to this, DeepSeek is also using mixture of experts. So each expert here is trained on a specific topic. Each expert here is trained on a specific topic. Let's say this one is trained on law. This one is trained on product. This one is trained in IT. This one is trained in mathematics. Given a question as an input, like how we ask these models a question, given a question to these models, depending on the question type, it is going to activate one of this expert. Either this one, or this one. And how do we control it? We control it with a gating mechanism. So as described here in the structure, so when we discuss about MOE's architecture for DeepSeek, we have an input coming in from the user. This input is so we have an input coming in from the user. First, the context of this input is understand and it is stopped at this gate. On the other side of the gate, we have n number of experts, each trained for a relevant task here. Depending on the context given by the user, this gated architecture is going to allow one of these one of this expert to give the answer. So in the backend, these experts are answering for us, but only the expert that is relevant to this use case will be allowed, and the gate is going to allow the expert to pass the solution. So what is MOE? It is a mixture of experts in neural network architecture that selectively activates only a subset of its parameter for a given input. This allows scaling up the model size without increasing inference cost proportionally. So we came across this concept that DeepSeek has been trained on 1/10 money of GPT. How is it doing it? It is doing it by restricting the attention heads that we call in other words. Instead of activating each and every head for a given corpus, it is activating only a small subset given the input. From this subset, only the relevant output is going to pass through the gate here. So the core concepts when we are discussing about DeepSeek is the experts that we have, independent networks inside the architecture, the gating network that determines which expert to allow to pass through, And sparse activation. Instead of activating every expert, it is only activating a small number of experts relevant to the use case. Now the amazing stats are over here. The model size is 236 billion parameters. But on a given input, it is only activating 39 billion parameters. But on a given output, it is only activating 39 billion experts. It is trained on 2 trillion tokens mixed with English, code and Chinese. Efficiency activates only 2 experts per token sparse MOE. Hence, inference cost is comparable to a 39 billion dense model. Routing based on token feature. The gating network decides which expert to use. Benefit, scalability, large capacity, low inference cost. That this model is capable of performing many things. It has a large capability, but during prediction, it is not activating all the capabilities. Only the one that has been used for the input is being activated. That is going to reduce the hardware cost. Now, specialization, as discussed, each of these experts are trained on a specific use case. So when we are asking the questions, only those experts are giving us responses. And let's compare this. So this one here we discussed how DeepSeek's MOE architecture is going to work. Let's compare it with ChatGPT's architecture. So when we discuss about ChatGPT's architecture, it is a traditional large language model training where we are going to collect data in a supervised manner. So we are going to collect a huge number of data depending on the use. So here we are going to collect a huge data and train a supervised policy. A prompt is sampled from a data set. So here when we are generating this policy, so we have collected the data and the data is passed into the training inference. This training inference is going to start learning from the data. Using the encoder-decoder network that we have, it is going to start learning from the data. Like how a human learns when we start given this entrance and given this exit. A blindfolded human is supposed to reach over here. What are we going to do in this case? First, we might hit this wall. We might continue straight until we hit this wall. We might hit this wall and continue straight until we hit this wall. We might take a left and we have found exit. Same approach has been taken by ChatGPT's architecture. That is called as RHLF, reinforcement learning from feedback. So once the data is collected in a supervised manner, that is identifying the good data and identifying the bad data and removing the bad data, the machine is allowed to predict repeatedly. The machine is allowed to repeat predictedly. When the machines are predicting correctly, the machine is giving reward. When the machine is predicting incorrectly, it is penalized. And this is how, looking at the same structure, the machine is going to optimize until and unless it is starting to give us more and more relevant outputs here. So when we look at ChatGPT's architecture, we have collected the data set in a supervised manner, that is human extensive, where humans are labeling the data, either it is good or it is bad. Once the label is done, next the data is passed into the machine learning algorithm. Here the ChatGPT's network is going to start predicting the values for us. If the value predicted is correct, there is going to be a reward to it. If the value predicted is incorrect, there is going to be loss to it. Depending on this, once the model is trained, we are going to optimize the policy against the PPO and we are going to get the finally trained model here. So what is RLHF that I had discussed on the previous type? It is a fine-tuning process where a large language model learns to align its responses with human preferences using reinforcement learning. That is, given a sentence, given a sentence, the machine is going to come up with a sentence and the human is going to label that sentence. If the machine has labeled it properly like human, there's going to be reward attached to it. Otherwise, there's going to be penalty. So the entire training pipeline for GPT, to sum it up, we have a pre-training pipeline like an MLM model that is going to standard the transformers training. So that is going to standardize the model's input weights. After this, we have supervised fine-tuning models, where human laborers write idle answers for the prompt, and that is compared whether the answer given by the model is correct or if the answer given by the model is incorrect. For every correct response, the model has a reward, and for every incorrect, it is penalized. To optimize these rewards and penalties, we have a reinforcement learning policy here that is going to optimize these rewards and penalties. Key features about RLHF is 1. Human feedback loop. This leads to higher alignment and helpfulness. The quality of the data is in place here. Second, safety tuning. Additional human feedback is used to reduce hallucination and harmful outputs. If the input is just how are these models training, depending on the daily input coming from the users, they are reusing it for retraining. Definitely inside those prompts given by the user on daily basis, they are going to be very harmful, factually incorrect prompts. So a human person is going to remove that and only pass the relevant prompts here. So examples for use in GPT, the difference between GPT-3 and ChatGPT largely stems from RLHF. ChatGPT is trained to follow instruction, refuse unsafe queries, and maintain conversational flow. These behaviors emerge from RLHF fine-tuning. Let's look at the summary table. How are they different? So for DeepSeek, we have this sparse mixture of experts. All the attention heads as an expert that is going to learn from the data, but only a subset of it is going to be activated. On the other hand, here the data that has been passed to the machine, the data has been generated by human and the comparison is done with the data generated by machine to check how relevant or irrelevant the answer is. Purpose for doing this is efficient scaling of model size. We must have come across ChatGPT has consumed billions and billions of dollars to train that model. So to overcome this thing, instead of using each and every attention head inside the model, here the MOE is using only a subset of heads. Inside ChatGPT, the benefit here is the data generated and shortlisted is by humans. So there is a less chance of irrelevant prompts here. Architecture, experts and gating network, whereas ChatGPT is going to use single dense transformer architecture. Efficiency, only 2 expert active for token. ChatGPT, it is going to use entire experts or entire attention hits for inference. Training data used is only 2 trillion tokens, multilingual, that is in English and Chinese. Whereas ChatGPT is used the entire public web data and also the human created dataset. Alignment strategy, that is retraining strategy, is specializing via routing, the gated architecture, and for ChatGPT, it is through the reward model and human preferences. Thank you.